Hello everyone, welcome to Abhi online classes. Today we are going to discuss two more theorems, Cauchy nth-root test and D'Alembert's ratio test in infinite series. First we see Cauchy nth-root test. Let sigma un be a series of positive terms such that limit n tends to infinity nth root of un equal to L. Then sigma un converges if L less than 1. Sigma un diverges if L greater than 1, and this root test fails and the series may converge or diverge if L is equal to 1. That means for L is equal to 1, root test fails. Now we see second test, that is D'Alembert's ratio test, which is also called ratio test. Let sigma un be a series of positive terms such that limit n tends to infinity un plus 1 by un equal to L. Then sigma un converges if L less than 1. Sigma un diverges if L greater than 1. The test fails to decide the nature of the series if L is equal to 1. That means here also if L is equal to 1, ratio test fails. Previously we have discussed root test. For L is equal to 1, root test fails. Here also for L is equal to 1, ratio test fails. Now we will see one problem. Test for the convergence of the series sigma n plus 1 by n plus 2 whole power n into x power n, where x is positive. Now we'll see this problem. Here nth term is un equal to n plus 1 by n plus 2 whole power n into x power n. We take nth root on both sides. Cancel power n and nth root. Therefore, nth root of un is equal to n plus 1 by n plus 2 into x. Now apply limit on both sides. Limit n tends to infinity nth root of un equal to limit n tends to infinity n plus 1 by n plus 2 into x. Limit n tends to infinity, we take n common, n into 1 plus 1 by n, by here also n common, n into 1 plus 2 by n into x. Cancel n. Limit n tends to infinity means 1 by n tends to 0. Therefore, this is equal to 0 and this is also 0. 1 plus 0 by 1 plus 0 into x is equal to x. Therefore, limit n tends to infinity nth root of un is equal to x. Therefore, by Cauchy nth root test, sigma un converges if x, that means this L, x less than 1, this series is a convergent series. If x greater than 1, sigma un diverges, and this root test fails for x is equal to 1. Now we see for x is equal to 1, un is n plus 1 by n plus 2 whole power n into 1 power n. 1 power n is nothing but 1. Now we take n as common in both the numerator and denominator. N power n into 1 plus 1 by n whole power n by, again we take n as common, put power n power n into 1 plus 2 by n whole power n into 1. Cancel n power n. Now we apply limit n tends to infinity on both sides. Therefore, limit n tends to infinity un is equal to limit n tends to infinity 1 plus 1 by n whole power n by 1 plus 2 by n whole power n into 1. Limit n tends to infinity 1 plus 1 by n whole power n is equal to e. In the same way, limit n tends to infinity 1 plus 2 by n whole power n is equal to e square. Now we cancel e. Therefore, 1 by e, which is not equal to 0. Limit n tends to infinity un not equal to 0 means definitely this series is a divergent series. Therefore, for x is equal to 1, our series is a divergent series. So finally, for x less than 1, sigma un converges. For x greater than or equal to 1, this series is a divergent series. Now we'll see one more problem. Test for the convergence of the series 1 plus 2 power p by 2 factorial plus 3 power p by 3 factorial plus 4 power p by 4 factorial and so on. Here nth term is n power p by n factorial and so on. This is the infinite series. Now we test the convergence of this series by ratio test. Here we take nth term un as n power p by n factorial. Now replace n by n plus 1. Un plus 1 equal to n plus 1 whole power p by n plus 1 factorial. Therefore, un plus 1 by un is equal to this by this. This is equal to n plus 1 whole power p by n plus 1 factorial into, we take reciprocal, n factorial by n power p. Cancel n factorial in n plus 1 factorial, which is in n plus 1 times. Therefore, un plus 1 by un is equal to, take n as common and put power p for both the brackets. N power p into 1 plus 1 by n whole power p by, here also we take n as common, n into 1 plus 1 by n into 1 by n power p. Cancel n power p. Apply limit n tends to infinity on both sides. Limit n tends to infinity un plus 1 by un is equal to limit n tends to infinity 1 by n into 1 plus 1 by n whole power p by 1 plus 1 by n. As we all know, n tends to infinity is nothing but 1 by n tends to 0. This is 0. 1 plus 0 whole power p by 1 plus 0. 0 into something is 0. Therefore, we got 0. This is less than 1. Therefore, by ratio test, this series is a convergent series. This is the procedure for the test of the convergence or divergence of the given series by using root test and ratio test. Hope you understand this class. Thank you.